Hello everyone, welcome back to the class operating system. Last class we have talked about the efficiency, user convenience and also a system performance. And also we have talked about how to measure the user convenience and the system performance and also efficiency. And also we have talked about the basic classes, what are the classes of operating systems and what is the basic concern of that. And also we have talked about the whatever the concept which is used in that classes of operating system. So this is what we have discussed in the last video. So in this video we are going to talk about in detail each and every classes of operating system. Okay, so the first we are going to talk about the batch processing system. So the computer systems of 1960s were interactive. So the punched cards were the primary input medium. So the jobs and its data consisted of the deck of cards. Okay, so the computer operator would load the card into the card reader to set up the executions of the job. So during this action there is a possibility of wastage of CPU times. So the batch processing was introduced to prevent this CPU wastage. Okay, so the batch is nothing but what first? So the batch is nothing but the sequence of user jobs formed for processing by the operating systems. So the set of user jobs are formed combined together to form a batch. Okay, a computer operator formed a batch by arranging a few user jobs in a sequence and inserting a special marker cards to indicate the start and end of the batch. So otherwise we doesn't know where the batch starts or where the batch exactly it ends. So the operator will combine the number of user jobs are together to form a batch and indicate the special marker card to indicate start and end of that particular batch. Okay, so after initiating that, the batching kernel will initiate the processing of the job without requiring the computer operator interventions. Okay, so once the operator gave the command to initiate processing of that batch, so that batching kernel will initiate the process. Okay, so will initiate the process of the first job of batch. And at the end of the job, it initialized the executions of the next job. It initialized the executions of next job and so on. It will be continue until the end of the job in a batch. Okay, so during this batch processing operation, node need to involve the operator. Okay, so the operator involvement not required during the batching. Okay, in between the job changes, it's automatically shifting the job executions from one to the another. It is not required to execute, it's not required the operator intervention. So in earlier, for each and every job, the operator need to put into the execution under the CPU. The CPU will execute. After that, once if it is completed, it will be removed from the CPU, and again the operator need to insert the another job into the computer systems, and if it is completed, then it must be removed. So like that it was. Okay, so to avoid that CPU idle time, this batching kernels were created, the batch processing systems were created. Okay, so here the group of jobs are combined together to form a batch, and then while executing the batch, the operator will insert the batch into the computer. Okay, after marking the special marker starting and ending of the batch, after that it initiate the kernel, the operating kernel will initiate the executions of the first job, and automatically it will take the second job and third job until the completions of that last job in a batch. So it will be automatically executes. Okay, so the operator involvement is not required during the batch operations. Only the operator had to involve only at the start and end of the batch. Okay, so and the card reader and then printers were a performance bottleneck in 1960s. So the virtual card readers and printers implemented through the magnetic tape were used to solve these problems. See, actually the card readers and then printers that means the performance bottleneck in the 1960s. So during that time the virtual devices were implemented. Okay, so the virtual card reader and then printer implemented through the magnetic tape. Okay, so that was used to solve this particular problem. So by using that we can improve the throughputs. Okay, so first the batch of jobs was first recorded onto the magnetic tape, okay, using a less powerful and cheap computer, and the batch processing system processed these jobs from the tape, which was faster than the processing of the particular cards, and wrote their results onto the another magnetic tape. Okay, so uh, these informations later printed and also released to the user. Okay, so here the virtual concept, the virtual resource concept is also used. The virtual card reader and printer are also implemented to increase the throughputs. Okay, so first whatever the user jobs are there, that will be recorded onto the magnetic tape by using the less powerful and also a cheaper computers. After that it will be processed. So once the processing are done, and that result will be stored into the another magnetic tape. If it is required, then that will be print into the that particular document will be printed, or it will be give it to the user, released to the user. So this is what the operation which is behind the batch processing system. Now, so I have told you that turnaround time. So we have talked about the turnaround time. Okay. So what do you mean by turnaround time? Already we have talked in the last previous topics, turnaround time. Um, Here we are going to talk about with timing details. Okay, so in this figure you can see here that at the time t0, at the time t0 job is submitted. So the job is nothing but what? Any of the user request. It may be on process or it may be on any of the request. So the user request submit at the time t0, at the time t1, between the time t0 to at the time t1. So the batch formations and all done. Okay, so the batch is formed at the time t1. So the time between t0 to t1, the batch formations are done. Okay, and at the time t2, the time between t1 to time t2, the batch executions takes place. The batch is nothing but the group of jobs. Okay, so the group of job executions are done during the time t1 to t3. Okay, and after that the result will be printing during the time of t2 to t3. The result will be printing during the time t2 to t3. So at the time t3 the results are returned to the user. Once the results are printed, then the particular result will be given to the user. So the turnaround time is nothing but the time taken between t0 to t3. That means that the time between the job is submitted to the results are available to the user. So that is called turnaround time. The turnaround time simply it is nothing but the time taken between the request is submitted to the results are available to the user. So this is called turnaround time. Okay, so for example this job will be submitted at the time of 10 seconds, at the time t is equal to 10. Okay, at the time t is equal to 10. So now the results are available to the user at the time t is equal to 15. For example, the t is equal to 15. So the turnaround time is nothing but the time taken between 10 to 15. So the turnaround time is nothing but 5. T is equal to 5. So this is how we can calculate the turnaround time. Okay. So the next is the user jobs could not interfere with each other's execution directly because they did not coexist in the computer's memory. So one job should not interfere with the other's job. directly it should not be interfered. If there is any call or if there is any request from that particular job or request, then you can that particular job can be accessed by that particular program, or otherwise it cannot be accessed by others program. Okay, so because that particular program did not coexist in the computer memory. So however, the card reader was the only input devices which was available to the users, and the commands, user programs and the data were all are derived from the card readers. So if the program in the job tried to read more data than provided in the job, it would read a few cards of the following job. Okay, so because the group of jobs are combined to form a batch, so the operator will fix the special marker card to start and end of the batch, right? So, but here, if the program wants to read the more data, then it's try to read the other batch in the other batch jobs. Okay, that is a possibility of reading the other jobs in a batch, right? Right. So, um, so to protect against such interference between the job, a batch processing system required a user to insert a set of control statements in the deck of card. So there is a control statement to protect against these kind of interference, that reading the data from one to the another, one batch to the another batch. It's not supposed to read the data from the other batch. Okay, so to avoid such kind of interference, there will be a control statement. So that control statement which is used to protect against the interference between the job. Okay, so and the command interrupter. Okay, so the command interrupter, which was a component of the batching kernel, that reads the cards when the currently executing program in the job wanted the next card. Okay, it will read a card when currently executing the job in program in a job wanted the next card. So if the card contained a control statement, it analyzed the control statement and performed the appropriate actions. So otherwise, it will pass the card to currently executing program. Okay, so that is a control statement. The control statements are // this is the example of Java program. Okay, so the /job, that means that it indicates it's a start of the job statement. So when we are starting the start of the job, it must represent /job and the execution of 14 instructions. So the set of 14 instructions are there up to here. So up to here the set of 14 instructions are there, and after that /* and that indicates the end of the data statement, end of the data, and the / and symbol that indicates end of the job statement, end of the job statement. So if that particular command, I mean the operator, I mean what is the batching kernel, it reads this particular control statements, then it will come to know that particular data are ended and then end of the jobs. So that particular job is also ended. So it will read the another job in a batch. And also we have talked about the special markers, right? So if it will read by the special marker symbol or the command which is there, the batching kernel will come to know that that batch is also completed. So that particular result will be returned to the user or the other operating system, I mean the other input output devices. Okay. Okay, if it is apart from that, if it is trying to read more data, then that particular program will be aborted. Okay, so these kind of operating system which was not there in the modern operating systems, but it is still useful in financial and then scientific computations. Okay, where the same kind of the same kind of processing or analysis is to be performed on the several set of data. So during this point, for this application, these kind of process are used. Okay, but modern computer system, this batch processing was not there. Batch processing is not there, but still it is used in financial and also a scientific computations. For example, your credit card calculations, credit card bill calculations. So how they were calculating the credit cards? So the batch, the group of jobs are formed like on batch. So I can consider whenever you are swiping, whenever you are using the credit cards, that is one job. Okay, so the batch is nothing but, so I can consider the start date and end date. Okay, so for example, the month starting and month end is nothing but the special marker, that is my the batch. From this time to that time, my group of batches under formed, I mean the group of jobs under framed. Okay, so this is my batch, so I want to execute that particular batch. Okay, so these batch can be executed only after the 30th of that particular month, end of that month. So after that end of the month, 1 or 2 days, that result will be available to the user, that is the how much the credit card amount used, purchased. So that information will send to the user. Okay, so for these kinds of operations, the batch processing systems are used. Is clear? So this is all about your batch processing systems. Next, multiprogramming systems. So in multiprogramming system and also a batch processing systems were implemented in 1960s during the non-interactive environment. Okay, so these two systems are non-interactive environment systems. Okay, so the main aim of this multiprogramming system is efficient usage of resource, efficient utilization of resource. That is the main main motto of this multiprogramming systems. Okay, so and what do you mean by first multiprogramming? A multiprogramming OS that has a many users programs in memory at any moment of the time. Okay, so that's why it is called the multiprogramming. Multiple programs are available in memory at any moment of time. So it is called multiprogramming. And this multiprogramming system which employs the DMA mode of operation, DMA mode of input output. That means that what? It can perform the input output operations of some programs while using the CPU to execute some other programs. So here the CPU also executes one program, and IO is also the input output resource will also execute some other program, so that we can increase the efficiency of resource utilization, and also we can increase the throughput. The number of programs can be executed at per unit time, it may increase. So by using this DMA mode of input output operation, we can increase the efficient usage of resource and also a throughput. So this arrangement makes the efficient use of both the CPU and also IO devices. So this input output and also the computational activities in several programs are in progress at any time. So it also leads to the high system performance. Clear? So the CPU will also execute one program, input output also executes one program, so that the computational activities will perform at any moment of the time, so that the system performance will also increase. Okay, so that system performance will be calculated through the turnaround time. So the turnaround time of the program is the appropriate measures of user services in these types. So the depending on the user services, how many number of user services are completed during that time. Okay, so how much time taken to complete that particular process, so that the system performance is also increased, the user efficiency, I mean the efficient usage of the resource is also very good in multiprogramming systems. Okay, now see in this example, in this figure you can see here the operations of the multiprogramming systems. See here in this multiprogramming kernel, consider this is like on memory. Okay, so in that memory I have 3 programs, the program 1, program 2 and program 3. So if you can see here, the program 1 which executes under the CPU, which executes under the input output operation, and program 2 which executes under the CPU. Okay, once this execution is completed, that particular resource will be shifted to the other program. See, in the second diagram, if you can see here, the program 2 completed the CPU operation and that will be switched to the program 3. The CPU will be switched to the program 3. But the program 1 still it is executing the input output operations. Okay, and if you can see here, in program 2 itself, in the figure B itself, if you can see the program 2 which executes the input output operation. So it's completed the CPU and it's executing the input output operation. And the program, in figure 3, if you can see here, the program 1 is completed the input output operation and the CPU which is switching between the program 3 to program 1, because the program 3 completed the CPU operation, so that particular resource is allocated to the program 1, right? So the program 2 still it is executing the input output operation. So if you can see here, at any time, for example in figure B, at the time t, the program 1, program 2 and program 3, both these 3 programs are executes under the IO and also a CPU resource. Okay, so that the system performance, throughput and also the user services are very good in this multiprogramming, and resource utilization also very good in this multiprogramming systems. So to perform the scheduling, to perform the CPU execution, so for that we need a scheduling operations, right? So in this multiprogramming system which uses the simple scheduling policy, and the resource like an input output and also a CPU must be allocated to the each and every program. It is like a resource. According to the program, it is like a resource. That resource will be allocated to the specific program. For that we need a resource allocation technique. So here this multiprogramming system which uses the simple partitioned or pool based allocations of resource allocation, that is memory and then IO devices, input output devices. The simple resource allocation techniques, that is simple partitioned or pool based allocation, are used. Okay, and so this multiprogramming kernel which performs scheduling, memory management and also the input output management. Okay, now the next. So what are the architectural support for this multiprogramming? So the features, what are the features of this multiprogramming systems? So the one is DMA and second one is memory protection and third one is kernel and then user modes of CPU. So the DMA is nothing but we know that it is direct memory access. So the CPU initiates an input output operations when an input output instruction is executed. When it is executed, then it initiates the IO operations. Okay, initiates an IO operation when the input output instruction is executed. Okay, and the DMA implements the data transfer involved in input output operation without involving the CPU to raises an input output interrupt when the data transfer completes. Okay, so it without involving the CPU, it directly transfer the data to the input output devices. Once if it is the transfer is completed, then it will raise the interrupt, that is system call. Okay, so that is called the DMA, direct memory access. And the next one is memory protections, because the multiple programs are there in the memory, so they we need to access the data and also a code which is present in the memory. So the one program should not interfere the other program which is present in the memory, so that we need a memory protections. Okay, so the one of the features here is the memory protections. A program can access only a part of the memory defined by the content. So whatever the content which is present in the base register and size register, that particular data only we can access it. Okay, so and the kernel and then user modes of CPU. So there are two modes of CPU. There is the kernel mode and also a user mode. So we know that the kernel is nothing but an heart of the operating system. So the operating system only can access this kernel. Okay, so the kernel which executes in the background operations of the executions. Okay, so the certain instructions called the privilege instruction, that is a special kinds of instruction. that can be performed only when the CPU is in kernel mode. So when only the kernel mode. So a program interrupt is raised if the program tries to execute a privilege instructions when the CPU is in user mode. So when the CPU is in user mode, that CPU cannot execute the privilege instruction. If it is tries to execute the privilege instructions, then that time the interrupt will be raised. Okay, so that privilege instructions can be used only during the CPU is in kernel mode of execution. So already we know that the kernel, some kinds of resources are allocated to that kernel. Okay, so the CPU and IO, sometimes the CPU is required, the kernel which requires some kinds of resource like on CPU and IO devices. When that particular CPU is in kernel mode, then only we can use the privileged instructions, special kinds of instruction. Otherwise the CPU cannot use the privileged instructions. Okay, so these are the features of the multi-programming systems. And so now we have talked about the memory management and also the input output management and schedulings and all. Okay, and also we talked about the system performance is good, and also a user service is also good, the resource allocations and all. How to measure that system performance? The performance. So an appropriate measures of the performance of multi-programming OS is throughput. By using the throughput only we can calculate the system performance. Okay, so the throughput is nothing but what? The ratio of number of programs are processed and the total time taken to process them. Okay, so the number of programs or number of requests are completed per unit time, per the time taken to process them. So that is called the throughput. So by using this throughput we can come to know what is the system performance, the measurement of system performance. Okay, so this is called the measurements of system performance. And so the OS keeps enough program in the memory at any time, at all the times. So because the multiple programs are exist in memory, so one program which executes the CPU, another program which executes the IO operations. Okay, so at any time the multiple programs which is present in the memory. So it keeps enough program in the memory at all the times so that the CPU and the IO devices are not in idle stage. It will not be in idle, it will execute any one of the program. So that is called the degree of multiprogramming. So the degree of multiprogramming is nothing but the number of programs which is exist in the memory at any time. Okay, so and so for example, in the previous, if you can see in previous example, in the memory there are three programs which is exist: program 1, program 2 and program 3. For example, if all the programs wants to execute the only one resource under the CPU, it wants to execute only the CPU operation. So the IO devices will be in idle mode. So at all the times we cannot achieve the degree of multiprogramming. I mean the efficient resource utilization not possible at all the times. So that's why to achieve the good user services or the good efficient usage of resource. Okay, so to achieve that we are going to use the appropriate program mix of the CPU bound programs and IO bound programs. Okay, so to achieve that we are going to use two techniques. What are the two techniques? The one is appropriate program mix. So what is the appropriate program mix? Appropriate program mix is nothing but here we are dividing the program into two. One is CPU bound program and IO bound program. In CPU bound program, the CPU computations are more, IO operation is very less. And then IO bound program, the IO executions are more, CPU executions are very less. So after dividing that, depending on the requirement, the resource will be allocated to the CPU bound program and then IO bound program. Okay, and how to allocate that particular resource to the request? So that resource will be allocated depending on the priority. So we know that the priority is nothing but the numerical number is assigned to each and every process. When the process is created, during that time itself the priority will be assigned. So based on that priority, the highest number, that is the highest priority request. So that particular request, depending on the priority, the resource will be allocated. The CPU bound and then IO bound program, the resource will be allocated to that particular program, so that we can achieve the good utilization of the resource. good utilization of resource and also a user response, user convenience and throughput. So everything will be increased depending on the appropriate program mix. So if the appropriate program mix is very good, then we can achieve the throughput is also increases. If that is increases, then throughput is also increases. Okay, so these are the two techniques, the techniques of the multiprogramming. There are two techniques, appropriate program mix and also a priority based preemptive scheduling. So appropriate program mix, we are keeping the kernel keeps the mix of both a CPU bound program and IO bound program. So I have told you that the CPU bound program is nothing but the CPU involvement is more, IO operations is very less. IO bound program, IO is more, CPU is very less. So the next, the priority based preemptive scheduling. So we know that the priority is nothing but numerical number is assigned to each and every program, and preemptive is a preemptive. So when the high priority interrupts are occur, that high priority programs are occur, during that time the low priority interrupts are removed and the particular resource will be allocated to the high priority interrupt. So that is called priority based preemptive scheduling. So here the definition is given, the priority, a type rating criterion under which the scheduler decides which request should be scheduled when many requests awaits services. Okay, and see, if you see here in this diagram, the degree of multiprogramming, is increases when throughput is also increases. That means that what? The degree of multiprogramming is nothing but at any time the multiple programs which is present in the memory. So if it is present in the memory, and to achieve the degree of multiprogramming, we have a appropriate program mix and also a priority based preemptive scheduling. Appropriate program mix is nothing but what? Based on the CPU bond and then IO bond program. So based on that priority, the resource will be allocated. If this degree of multiprogramming is good and throughput is also increases. Okay, so when an appropriate program mix is maintained, an increase in the degree of multiprogramming, that would result in an increase in throughput. Okay, so this is all about your multiprogramming systems. So in multiprogramming, the main aim is nothing but the resource allocation, utilization of resource, and the user services and system performance. So this is the main thing in multiprogramming system. Hope this video is very helpful for you. We'll meet you in the next class. Thank you all.